The last way that we will talk about to solve a quadratic is using the quadratic formula. And the quadratic formula is fantastic because it is a way that always works. So just as always, we need everything in standard form, which is important. And then we just need to know what our a, b, and c values are. So the quadratic formula is what I've just put a box around here. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. There is a fun little Pop the Weasel song that goes along with that, which I will not sing for you, but you should Google it because it's funny. For this case, the first thing I'm going to do is, of course, put everything into standard form. So I'm going to move everything to the left side, which would be 2x squared minus 8x minus 90 equals 0. Now, in this case, I might also go ahead and take out a GCF of 2, but let's just do it without that for now, just for practice. I would then write down what my a, b, and c values are. So remember, a, b, and c come from the quadratic equation of ax squared plus bx plus c equals 0. So I'm looking for the a, which is 2, the b, which is negative 8, and the c, which is negative 90. Now, with the quadratic formula, I'm going to find my zeros by just plugging in all of those values and then calculating the result. So negative b, that's the opposite of b. So b is negative 8. I'm going to write the opposite of b, which is positive 8, plus or minus the square root. It's that plus or minus that gives us the two solutions. B squared, which is negative 8 squared, minus 4 times a times c all over 2a. Now, the more you do this, the less work you will probably show. I'm going to show as much as I can in this particular question. Negative 8 squared is 64. And then 4 times 2 times negative 90 is negative 720, but it's a minus negative 720, so it's really plus 720. All over 2 times 2, which is 4. If I add 64 to 720, I get 784. Again, still inside the radical. In this particular case, when I take the square root of 784, I get a nice whole number, which is 28. If I didn't, I would simply reduce it as much as I could by taking out a perfect square factor. And now I can find my two solutions by taking 8 plus 28 and dividing it by 4. Which is 36 divided by 4. Oops, divided by 4, which is 9. And then taking 8 minus 28 divided by 4, which is negative 20 divided by 4, which is negative 5. So my two solutions would be 9 and negative 5. Let's try another. This one's already in standard form for us. So let's write down our a, b, c values. A is 3, b is negative 4, c is 2. I'm simply going to plug those into the quadratic formula, which is the opposite of b, or 4, plus or minus the square root of negative 4 squared. So I'm just going to write 16. Remember, when you square a number, it's going to be positive. Minus 4 times 3, which is 12, times 2, which is 24. So notice I'm showing significantly less work on this one. All over 2a, so all over 6. That leaves me with 16 minus 24, which is, of course, negative 8. Still inside the radical. Oops, don't forget your negative. Now, of course, negative 8, I will write broken into negative 1, which is I, radical 4, which is 2, and radical 2, which of course doesn't come out. So this is 4 plus or minus 2I radical 2 over 6. I can go ahead and reduce this before I find the two solutions. To reduce, you're only taking the values that are outside of the radical, and of course I'm not going to be concerned about the I. So I'm going to look at 4, 2, and 6 and say, well, those are all even, so let's divide them all by 2, which leaves me with a 2 plus or minus 2 divided by 2 is 1, so it's 1I, or just I radical 2. 6 divided by 2 is 3. Now from here, of course, if I'm trying to write them as two solutions, I would write it as 2 plus I radical 2 divided by 3, and 2 minus I radical 2 divided by 3. Now, if they're super sticklers about it and they want you to write this as a complex number in that form a plus bi, that would of course be 2/3 plus radical 2 over 3i, and 2/3 minus radical 2 over 3i. So pay attention to how that you are asked to write that solution. Another practice for us, again, a is 2, b is -1, c is 2. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which leaves me with 1 plus or minus radical -15 over 4. Again, I can't really reduce anything there, but I can separate them into my solutions. So I would have x equals 1/4 plus radical 15 over 4i, and then 1/4 minus radical 15 over 4i. One for you to try on your own. So try this question, then press play to check your work. Here, a is 6, b is -5. Moving this 4 to the other side so that it's equal to 0, this would be -4 equals 0. So c is -4. Make sure you do that before you write down your a, b, or c values. Now I'm going to say x equals the opposite of b plus or minus the square root of b squared minus 4 times 6 times -4. And so I'm actually subtracting a -96, so I'm adding 96 all over 2a. If I add 96 and 25, I get 121. The square root of 121 happens to be a nice number. And now I can just find my two solutions. So my two solutions would be 5 plus 11, which is 16 divided by 12. 16 divided by 12, not a whole number, but I can reduce to 4/3. And then 15 minus 11, which is of course -6 divided by 2, which reduces to -1/2.